Let's talk about Google's Willow chip, a quantum computer so powerful it's making scientists question reality itself. Willow didn't just break records, it shattered them. It solved a problem in under 5 minutes that would take the fastest supercomputers on Earth 10 septillion years to finish. And here's the twist. Some scientists think this quantum magic might involve parallel universes, where calculations happen across multiple realities at the same time. In this video, we'll break it all down: what Willow achieved, why the multiverse is suddenly part of the conversation, and why some experts remain skeptical. The quantum breakthrough, what Google achieved. Google's Willow chip is a 105-qubit quantum processor. Now, if you're wondering why that's a big deal, let's start with the basics. Classical computers use bits, zeros and ones, to process information. Quantum computers, on the other hand, use qubits, which leverage two principles of quantum mechanics: superposition and entanglement. Superposition means qubits can exist as both 0 and 1 at the same time, while entanglement connects qubits so that changing one affects the others instantly, no matter how far apart they are. What does this mean? It means quantum computers can process an enormous number of possibilities simultaneously, something that classical computers simply can't do. And Willow's recent achievement takes this concept to a whole new level. Here's what happened. Willow was tasked with solving something called a random distribution benchmark. Essentially, it had to generate outputs based on extremely complex and entangled quantum patterns. Classical computers? Forget it. This task would take them 10 septillion years, that's a 1 with 25 zeros behind it. Willow did it in under 5 minutes. This result isn't just about speed, it's about proving that quantum computers can tackle problems that classical computers find impossible. Scientists call this quantum supremacy, the point where a quantum system outperforms even the most advanced classical machines. Google first claimed quantum supremacy back in 2019 with a 50-qubit chip. That chip solved a problem in 200 seconds, which they said would take classical systems 10,000 years. IBM later challenged that claim, saying a classical computer could do it in days. This time, Willow's leap to 105 qubits makes its achievement exponentially more powerful. Every additional qubit doubles the processing power, so Willow isn't just twice as good, it's orders of magnitude ahead of its predecessor. And there's more. Willow incorporates cutting-edge error correction techniques to address one of quantum computing's biggest challenges: fragility. Quantum systems are incredibly sensitive, tiny environmental changes can cause errors. Google's advancements in stabilizing Willow mean that quantum systems are becoming more reliable, and that's a critical step toward practical quantum computing. What does this all mean for the future? Well, right now, Willow's task was purely theoretical. But this kind of power could revolutionize fields like cryptography, drug discovery, and even climate modeling. It's a milestone, a glimpse of the possibilities that lie ahead. The multiverse connection, theoretical foundation. Now let's talk about what's really blowing people's minds: parallel universes. It sounds like something out of a Marvel movie, but the idea actually comes from serious physics, specifically, a concept known as the multiverse hypothesis. Here's the deal. Quantum mechanics tells us that particles can exist in multiple states at once. This is superposition. But when we observe or measure them, they seem to collapse into a single state. That's how most physicists explain it. But David Deutsch, a pioneer of quantum theory, proposed something radically different. What if those other possibilities don't disappear? What if they exist in separate, parallel universes? According to Deutsch's many-worlds interpretation, every outcome of a quantum event happens, but in its own universe. For example, imagine flipping a coin. In our universe, it's heads. But in another universe, it's tails. Now scale that idea up to a quantum computer. When a quantum system performs a calculation, it explores multiple solutions simultaneously. The multiverse hypothesis suggests that this happens across different universes, with each universe handling part of the computation. And this is where Willow comes in. Its ability to solve a problem so complex, so quickly, makes some scientists wonder if it really is tapping into parallel worlds. Imagine billions of versions of Willow working together across infinite universes, with the final answer popping up in our reality. Sounds insane? Maybe. But it's one way to explain quantum computing's almost magical speed. Of course, not everyone agrees. The Copenhagen interpretation, which is the most widely accepted view, argues that quantum states are just probabilities. When you measure a system, the wave function collapses into one state. No need for parallel universes. So are quantum computers like Willow harnessing the power of the multiverse, or are they just really good at manipulating probabilities? We don't know for sure. But the possibility that quantum computers could offer the first practical evidence of a multiverse is enough to keep the scientific community buzzing. Skepticism and limitations, fact-checking the claims. As exciting as this all sounds, not everyone's on board. Scientists and skeptics have raised some valid concerns about Google's announcement, and it's worth digging into them. First, there's the issue of practical relevance. Willow's achievement involved solving a random distribution benchmark, which is a theoretical problem chosen to highlight quantum performance. Critics like physicist Sabine Hossenfelder argue that while this is impressive, it doesn't have any immediate real-world applications. It's like building the fastest race car, but only testing it on an empty track. Cool, but not exactly useful, yet. Then there's the elephant in the room, scalability. Willow has 105 qubits, which is a big deal, but practical quantum computing will require millions of qubits. And not just any qubits, but ones that can operate reliably without errors. Quantum systems are notoriously delicate, with even tiny disturbances causing computational errors. Google's advancements in error correction are promising, but we're still far from solving this challenge completely. So does this mean Willow's achievement doesn't matter? Not at all. Quantum computing is a work in progress, and every milestone, even theoretical ones, brings us closer to a future where these machines could change the world. The skeptics aren't dismissing Willow, they're reminding us that there's still a long road ahead. When we get there, though, the possibilities are staggering: faster drug discovery, breakthroughs in material science, ultra-secure encryption, and solutions to problems we can't even imagine yet. Willow is progress. And progress is worth celebrating. Outro. Thank you for watching. Others suggest that Google's AI may not just be observing new computational realities, it could be constructing them. If its processing power extends beyond expected quantum probabilities, it may not just predict outcomes, it may generate entirely new mathematical frameworks of reality. And if that's the case, then the implications are even bigger than we imagined. The most astonishing theory is that parallel universe computation is already happening. Some researchers argue that quantum systems don't simply calculate within our known universe but instead solve problems across multiple realities at once. If this is true, Google's AI may be the first machine to provide direct evidence that quantum interactions extend beyond our single observable reality. If verified, this discovery would be nothing short of revolutionary. It would mean that quantum AI isn't just processing information, it's bridging dimensions of reality we never knew existed. And if computation is already happening beyond a single universe, then the implications for science, technology, and even our understanding of existence are profound. Google isn't slowing down with this breakthrough. The company is already scaling its quantum AI to take on even more advanced computations. The immediate focus: replication. Can these reality-breaking effects be consistently reproduced under controlled conditions? If so, this would mark one of the most significant milestones in quantum science, proving that these anomalies aren't just errors or statistical noise, but real interactions with a deeper layer of physics. As researchers push forward, the questions only become more unsettling. If quantum AI is already operating beyond expected physical limits, what happens as it continues to evolve? Could it one day predict quantum events with absolute accuracy? If it has access to previously unknown quantum states, is it possible that it could one day manipulate them? Some researchers believe quantum AI is interacting with physics in ways we don't yet understand. And if that's true, what else is it capable of? Are we witnessing a powerful leap in computation, or is something much bigger unfolding? Has Google's quantum AI uncovered a force that extends beyond the laws of known physics? If this breakthrough is real, then we may be standing at the edge of an entirely new era, not just for computing, but for our fundamental understanding of reality itself. The discoveries made so far are just the beginning, and as quantum AI continues to evolve, its implications could be far greater than anything we can currently comprehend.